what I was trying to do is test a type of embodiment that was shown in T.T. Brown's patent, which involved the use of triangular shaped dielectrics. And so anyway, so I hooked it up. I built this capacitor with layers of these dielectric sections. So the way I built it was like this. These foil, these would be the plates. So they're just stacked like that. So what's happening is it's arcing through here to the plate underneath. I got that crap all over my fingers. This is the profile here, the geometry inside. See, there's this triangular torus. I try to do like a layered dielectric. So I got this, this is like resin, urethane resin, and a powder of manganese dioxide. And then the rest I filled up with just resin. And then I stacked them. And what I was trying to do is see if I can detect any thrust. So I built this rotor, counterweight. There's a counterweight over here to balance it out. So there's a lot of inertia here because there's a lot of probably 5 to 10 pounds on here. But the bearing is pretty low friction. Seem to turn very easily. And then these are just hooked up to the Wimshurst machine here. So I didn't detect any thrust when I charge this thing up, which I'll do here. So to jump that gap right there, oh, that's about the width of my finger. Gives me a good zap. Let's see. Let's charge this thing up here. See if it moves. Also, this thing kind of jiggles around a little bit as I charge it. I thought that was kind of interesting too. See that arc over there? This is coated in multiple layers of spray-on rubber. Where is it? This stuff here, this is what I coated it in. Rubber sealant. I still got arc over. That's about 1 inch. 1 inch across. Or, 2.5 centimeters. That tells me the plates are collecting quite a high voltage. But yeah, that's a weakness in the device in terms of its maximum potential. You see that paper being pushed away when it arcs over. So anyway, I don't know if it's making any thrust. It's hard to tell. I'll reverse the polarity here. Yeah, because Brown states in his patent the making the dielectric converging or like a conical shape is supposed to enhance the thrust. So I wanted to try that. So polarity is reversed. I don't know which one is positive and negative. But anyways, I'm not seeing any thrust on this, which is sad. But I am seeing this other effect. Notice the paper is moving in towards the ends of the capacitor, only when it sparks. Now when I discharge the capacitor, they're pushed away. If you can see that on the camera. Now before, see that? It's quite an impulse there. So then it pulls it in. Now it's electrostatically attracted. If I discharge it, boom, pushes it away like that. I find that pretty bizarre. See that? This one was pulled in, this one was pushed away. See, they're pushed away when I discharge it, pulled in when I charge it. If I change the distance of the spark gap, so if when it sparks, there'll be more energy going into it. So you'd think explaining it just by electrostatic attraction, as these plates charge up, there'd be more of an electrostatic attraction. So once they're pulled in, they would be pulled in and they'd stay pulled in like that. But they don't. It's almost similar to the effect with an aluminum plate or a copper plate placed over an electromagnet that's fed AC current. There's a repulsion there due to the eddy currents. See that? This one was pushed away, this one was pulled in. Again, almost like there's a force, an impulse coming through along the axis. Again, see that? Now I'm going to reverse the polarity just by switching these electrodes around here. I could also reverse the polarity by just rotating this thing all the way around to the other side, but then it's hard to get the camera shot. So, alright, let's see what happens with that. Let's see what happens. Ooh-wee. And then it's pushed away. So that I can explain. It gains a bit of charge here, and then it's repelled because it has a similar charge on the surface. So that's no mystery. It's bizarre how, it doesn't stay pulled in, it briefly is pulled in and then it relaxes. So when I set all this up and when I built it, I wasn't actually looking for this particular effect here. And I'm going to do a little test on this guy here, which is another type of stacked asymmetrical capacitor I made. This is urethane plastic, so it's all nice and encased in that. Alright, so I'm going to crank this up. It's going negative there, apparently. So that's like, according to the scale, 130 milligrams. Like an upwards thrust. So I'll short it out here. It drops pretty low there. And it actually takes a while to discharge. I'm putting my hand just over top here. And now it's reading minus 0.5. Because it's attracted to my hand. But I'm basically discharging the thing here completely. See, I've got the generator shorted out. So there's this separation here from the scale. And this dish should reflect away any electromagnetic waves or interference. Still saying negative 0.22. This is a 500 gram limit scale, so I'm beyond that right now. But this is how I get around that. Just reset it. It still works. See? So I'll try reversing the polarity. See if we get the opposite. Okay, just reset that. Still going negative. Even more, 0.2. So apparently the Earth is negatively charged. So that might be a factor as well. Might be some electrostatic repulsion with the Earth. Which is still useful for getting off the ground. Negative 0.45 grams. So I'm getting much better results with this polarity. Couldn't tell you what it is though. And if I short it out, it goes even lower. So I think this effect of what I'm seeing on the scale here, and what for some time I've done a few videos about this, that it's related to the other effect there where you saw the paper moving with the spark discharges. Which leads me to the conclusion that this probably is something, you know, like a scalar wave, a gravitational wave, an electrogravitational wave. There's different names for it. I'm just trying to be really objective about this and not be too quick to just slap a name on it and call it this and call it that, but rather just to show you and to show myself the real nature of this stuff, and to see through, you know, what's reality here. And so this is shorted out right now. My hand is just over top, barely. So there's probably a little bit of a traction there. Now this is, so the only two plates that are electrified are the very top one and the very bottom one. There's there's 4 plates in between, but they would just be charged by induction, which is very, from what I could tell from T.T. Brown's original 1928 patent, is that he had, in his gravitator, he had multiple layers of cells, and each cell was separated by a plate of lead, I think, and then there was layers of dielectric. But he only electrified the very ends. separate the electrodes so they won't spark over. Discharge minus 0.4. Now what I'm going to do is flip this capacitor upside down. I'm just going to pause here for a sec. Alright, flipped over. Zeroed out. Looks like it's going a little bit negative. Discharge. Back to 0. Let's try one more time. Same thing. Discharge. Back to 0.